We here at the North Carolina Department of Agriculture are partnering with the NC State Extension to provide services that promote and improve agriculture, agribusiness, and forests, protect consumers and businesses, and conserve farmland and natural resources for the prosperity of all North Carolinians. So what does that mean for growers? We are here as a resource, support, and protection to help ensure that growers are able to come into compliance with the Food Safety Modernization Act's Produce Safety Rule. The goal of this video is to help you understand chlorine sources and the impact of microbial water quality used as agricultural water. Water is an important part of growing and maintaining produce on a farm. So naturally, we need to understand where the water is coming from, the possible contaminant elements and scenarios, and most importantly, how the microbial quality of the water impacts your crops and safety. Agricultural production water, or ag water, refers to water that is used during growing activities and is either intended to or is likely to contact the edible portion of fresh produce. Examples of agricultural production water include overhead irrigation, fertigation, crop sprays, and frost protection, to name a few. Surface waters used to irrigate crops potentially pose the highest risk, as they are exposed to environmental contamination, followed by groundwater and municipal water having the least amount of risk. Agricultural production water, particularly surface water including streams, ponds, lakes that have been contaminated with feces, have the potential to carry pathogens such as bacteria, viruses, or parasites. The water can serve as a vector or a carrier of pathogens to fresh produce. These pathogens could include enteric organisms such as pathogenic E. coli and Salmonella. Sources of pathogens could include direct contact with animals, or from contaminated water runoff from a nearby animal operation into surface waters. So, how do you maintain the sanitation of the ag water that comes in contact with your produce? Sanitizers and disinfectants, such as chlorine and peroxyacetic acid, are widely used throughout the food industry to treat agricultural water. These chemicals are considered antimicrobial pesticides, as defined by the Environmental Protection Agency, EPA. Specifically, antimicrobial pesticides are substances or mixtures of substances used to destroy or suppress the growth of harmful microorganisms such as bacteria, viruses, or fungi. Before use, these chemicals must be registered with the EPA. This registration process includes extensive scientific research on the potential health and environmental effects of a pesticide. Once granted a registration, the chemical is then licensed to be sold in the United States and must include a label that provides critical information about how to safely and legally use the chemical. These pesticide labels are legally enforceable. In other words, the label is the law. When using a chemical, there are several critical factors to look for on the label. These include registration number, understand state regulations or restrictions of the chemical, safe handling, where is the chemical approved for intended use, concentration or dosage of chemical to use, list of microorganisms targeted for specific use, chemical needs to be labeled for irrigation water. So, what are the differences between the two different methods used to treat ag water? Several commercially available treatment options exist. There are two types of treatments, including 1. Antimicrobial pesticides, and 2. Antimicrobial devices. The use of antimicrobial pesticides includes a substance or chemical intended to reduce the level of microorganisms in the water. This chemical, or sanitizer, must include EPA registration and approved for treatment of irrigation water. Examples of sanitizers used for irrigation water include chlorine, chlorine dioxide, and peroxyacetic acid. Antimicrobial devices, also regulated by the EPA, are instruments, other than a firearm, that are used to destroy, repel, trap, or lessen the severity of any pest such as insects, weeds, rodents, birds, mold and mildew, bacteria, and viruses. These are considered physical treatments and do not include chemicals. Examples of pesticide devices include filter units, ultraviolet light units, ozonator units. With many options for treating ag water, you may wonder about the pros and cons for each. When choosing a treatment, growers must evaluate each method based on its advantages and disadvantages, and decide which treatment works best for their operation. While there is no perfect system, some systems do have advantages that lend themselves as better options. Let's weigh the advantages and disadvantages of several treatment options, beginning with antimicrobial pesticides. 1. Antimicrobial pesticides. Chlorine is a very common disinfectant and is available in several forms, including powders, liquids, and gas. Chlorine dioxide is a gas most commonly produced by reacting sodium chloride with an acid. One of the most important qualities of chlorine dioxide is its high water solubility and its ability to remain a dissolved gas in solution. Peroxyacetic acid, also known as peracetic acid or PAA, is widely used for post-harvest washing of produce. PAA is a strong oxidizer made up of a mixture of acetic acid and hydrogen peroxide in an aqueous solution. 2. Antimicrobial devices. Ultraviolet or UV light includes the invisible spectrum of non-ionizing electromagnetic radiation and is separated into 3 categories based on wavelength. UVA has the longest wavelength, 320 to 400 nanometers, and is associated with sunburns and skin cancer. UVB, at wavelengths ranging from 280 to 320, is also associated with sunburns. However, this category is much weaker than UVA. The third type, UVC, measuring between 100 and 280 nanometers, has been used to disinfect drinking water, sanitize wastewater, and has been used in the food industry to sterilize food contact surfaces. According to the FDA, UVC between 200 and 280 nanometers is within the germicidal range and inactivates bacteria and viruses through changes in the chemical structure of DNA. 254 nanometers is the optimal wavelength for antimicrobial activity. Ozone is a powerful oxidizer, capable of inactivating a broad spectrum of microorganisms, including bacteria, bacterial spores, molds, viruses, and parasites. Ozone is a highly reactive, gaseous form of oxygen, consisting of 3 oxygen atoms. Now, pause the video and take note of which pros and cons would apply to your farm. Chlorine is a widely used, economical oxidizing agent that provides disinfection properties. Chlorine can be added to water in one of 3 forms: liquid, sodium hypochlorite; solid, calcium hypochlorite; and gas, liquid chlorine. Chlorine kills bacteria by attacking the cell membranes. Hypochlorous acid enters the cell wall with water and breaks down the enzymes in the cell wall. Chlorous acid is more of a tiny hammer to bacteria. When chlorine gas is dissolved in water, it reacts to form hypochlorous acid, HOCl, and hydrochloric acid, HCl. Cl2 plus H2O equals HOCl plus HCl. Hypochlorous acid further dissociates into the hypochlorite ion and hydrogen, following the equation. Chlorine is most effective as a disinfectant as hypochlorous acid, followed by the hypochlorite ion, OCl. The concentration of these 2 forms are highly dependent on pH. Depending on the pH of the solution, 3 products, i.e. Cl2, HOCl, and OCl, can be present alone or in combination. The sum is referred to as available chlorine or free chlorine. At 25 degrees Celsius and at a pH of 7.5, half of the chlorine is present as the undissociated HOCl, and the other half is in the form of dissociated OCl. At pH values higher than 7.5, the predominant form is OCl. While below 7.5, the hypochlorous acid is most abundant. At pH 5, the chlorine is present mostly as hypochlorous acid and in its most effective form. Chlorine kills bacteria by attacking the cell membranes. Hypochlorous acid enters the cell wall with water and breaks down the enzymes in the cell wall. Here is Chip to explain the different methods of measuring the chlorine in ag water.
Chlorine has certain advantages and certain disadvantages. One of the disadvantages of chlorine is that it is most effective at pHs above 6.5. So you have to understand the pH of the water when taking into account the amount of chlorine that you're dosing. For chlorine, there are two different types of measurements that can be done, either free chlorine or total chlorine. Total chlorine is both the free chlorine and then that is combined with other particulate matter or with nitrogen that might be in the water. So it's most important from a grower's perspective to measure the free chlorine in the water. Here we have two different test kits. One of these is for ultra-high chlorine concentrations, and you can see that the range for that is from 0 up to about 750 milligrams per liter or parts per million. Most growers would be interested in using much lower concentrations of chlorine than that, and so this would be more appropriate. These test strips measure from 0 up to about 25 milligrams per liter. In addition to the test strips, we have two different chlorine meters. These are relatively expensive. One of the disadvantages of this type of meter is that it can only measure up to 2.5 milligrams per liter, but it's relatively inexpensive, less than $100. This meter will go up to 5 milligrams per liter, and it is more expensive, but it's still less than $400.
Now that you are familiar with ag water and the risks associated, EPA labeling, and why it is important, as well as the basics of chlorine chemistry and which methods are available for treating water, we hope that you will carry on this information to your team for the best success on your farm.